There are a couple of challenges when we talk about data warehouse cloud native. First of all, security. When we talk about data, that means that probably we will be dealing with personal information, sensitive data, such as bank account numbers, addresses, phone numbers, you name it. All that data needs to be securely, and you should be able to keep it inside your data warehouse encrypted. And to do that, it is also needed that through the whole process of all the transformation series, that data is correctly encrypted in each one of the steps. And to do that, a correct data lineage is needed. The second challenge is consistency. For example, if you have a company that has 5 different teams that are trying to develop their own data warehouse, then all of those teams need to have a standardized approach when it comes to delivering the data warehouse project. Same in that line of the consistency, when delivering the data warehouse changes, needs to happen only once, right? Like it needs to be developed, and it should be possible to deploy it as easy and as smooth as possible. Other of the challenges when it comes to a data warehouse is that the data needs to be discoverable by all the users. That means technical users, business users. And for business users, it's important to understand what data exists to potentially come up with new questions that hasn't been thought about, for example. And then the technical users can really come up with better transformations to try to answer those questions that are coming from business. Another challenge as well is the complexity. The complexity that comes with a cloud-native solution. How do you set up a project in GCP? How do you define which pieces of your data warehouse will be in which project? For example, does your data mart needs to be in the same project as your data lake? All those things that comes with those questions that comes with a cloud-native solution. So that's where Flycs really comes in play. Flycs is trying to solve all those issues and all those challenges one by one. For example, for the security, Flycs allows you to do some PII tagging to define which are the sensitive data existing, which fields of sensitive data exist in your data warehouse, and allows you to encrypt all that data. And the encryption happens through all the different steps in your transformations in the data warehouse. Also, Flycs allows you to deploy in a consistent way your data warehouse changes. As well, since it's a framework, that means that if you're working with a group of developers and you have different teams developing different data warehouses, that means that that same framework and that same way of working can be applied through all the teams. That allows to really deliver the same data warehouse project, well, at least the same approach for delivering the data warehouse project in a consistent way. And as well, Flycs leverages data catalog that allows you to have a good visualization of all the different tables and fields that exist for your data warehouse. Since it's a framework, that means that it's all the complexity of coming up with your with the own idea of a data warehouse. It's already predefined and well taught to how to solve it. For example, the setup of the infrastructure as a code, or the definition of the IAM policies to be applied on top of your data warehouses. So here we can see a modern data warehouse project. All the way to the right, we have the sources where, for example, can be an ERP system or a CRM or any databases. All that data then comes into BigQuery, and you can make the ingestion by leveraging something like Fivetran, Devoteam, you name it. Then you can see that the real power starts with Flycs when we start to talk about transformations. The first transformation layer comes from the raw area. The raw area is just an area where it's the landing place for all the data that is coming straight from your database. The second layer is the real data lake area, where you will have your encrypted data and historized data. And in this area, you will like to keep all the history of your tables, because imagine the situation that a customer changes name. So that means that 1 month ago, you sold something to someone, to the same customer that at that point was called Robert, and then changed his name to John. So it is important in the data lake to have a clear historization of all the different points and how does all of the data is changing. And of course, that name needs to be encrypted. So it's important as well to leverage that PII encryption. The next layer, we have the staging area. The staging area really becomes more of a that's where really the modeling for business starts. When potentially you have the customer concept for business that is not only what you have in a ERP system, but also needs to be enriched. That customer concept needs to be enriched from a different database that you have somewhere else. So the staging area really becomes the part where you would start modeling for the business. Then we have the data warehouse area. The data warehouse is going to be that historized version of your transform layer in the staging area. So the same customer that we discussed that changed name Robert to John or John to Robert, it will show up as well in your data warehouse historized versions, plus all the different aggregations or all the different enrichments that you do for that customer concept that is coming from business. So the last layer as well, we have data marts. The data mart is really to expose the data that you pre-modeled before to other consumption layers. For example, a machine learning team will like to do some modeling on top of your customers and your sales. But then it might not be that interesting for them to have access to all the data lake. They only need the pre-modeled data. So that's why a data mart becomes interesting. Or as well, to have an API that serves the data for an end user. And as well, the most use, the most use case is to come up with a BI report, right? With a tool like Looker or Data Studio, plug it into a data mart, plug it into even to your data warehouse, and make it available for the analysis of your users. So all of these transformations are actually managed by Flycs, right? This becomes tasks in something that is called Composer, and Composer is the Airflow managed solution. And this Composer is leveraged by Flycs to then define the tasks, and it is important to notice that we're using Composer because it is not only about transformations, and we will see it in a couple of slides later, that we can do more than just managing transformations. It's also about potentially using custom codes. Maybe at the end of your pipeline, you want to trigger a step for a third-party API. You want to let the third-party API know that your process is done. So inside Flycs as well, the definition of the IAM is pretty fine. So that means that, for example, an end user, that a business user would like to have knowledge over your customers might only need access to your data warehouse, but not might be so interesting for that user to have access to the data mart that the machine learning team is actually using. So that's where also Flycs comes into play. And all of that as well while leveraging monitoring and logging and notifications while using Stackdriver. So Flycs can send notifications to Slack channels and also G-Cloud chats. Like you can send chats to the chat channel as well. And yeah, you have a lot of options when it comes to notifications. So just an example as well, here is just a typical SQL statement. The thing that is interesting to notice is in case that we are selecting the name of the customer, for example, then for the data engineer that is working with it, it's become transparent. There is no complexity added if it's a PII tag or not. Is a PII tagged field, yes or no? It doesn't really matter. For the data engineer itself, it's going to look, it will need only to write the SQL code as it will do for any other field. So if you want to concatenate two different fields, and one of them is actually a PII field, it should be possible and simple and straightforward for a data engineer. What's also important to notice is that all the different tasks that we discussed about staging and then as well data warehouse and data mart, all of them have a dependency. That dependencies are solved by Flycs by noticing where is it coming from and noticing that just by reading at the from statement, for example, to say this table is actually relying on this other one and this another one, and then create a dependency tree. This is an example of how it will look like then the dependency tree when it now becomes a DAG. So as you can see, not all the data warehouse tables needs to wait for example, for all the data lakes tables to be finished, right? For example, for your customer table, maybe the vendor table the vendor tables are not needed. So the dependencies are solved by Flycs to knowing exactly where all the things are coming from. So what's really trying to Flycs solve is actually about time, and to allow the companies to focus on what's important, on the insights, and to model the data, because the way of approaching a data warehouse project, it can be the same through different companies, but what's really important is the way that data is modeled between companies and what questions are asked in those companies. So such things like PII management, how to test your DAGs, how to orchestrate your transformations, how to keep a good versioning, how to do monitoring, and all those things that are actually things that are very well defined inside Flycs frameworks, and the idea is just that allows you to focus on the insights. In a typical project for Flycs, without Flycs, you will start in Q1 by defining, for example, the DevOps approach, or the infrastructure as code, what needs to be deployed, how to deploy one thing or the other, or all, and then in Q2, finally, you will start probably doing something with Composer, start configuring to have it ready for your task dependencies, start solving all that task dependencies needed. And then in Q3, then PII tagging might come in place to really be able to be GDPR compliance. Start adding some IAM on top of your data that exists. And then finally, on Q4, there is going to be the business logic, what really matters to the business, right? What really is important for the company that you're working with. So the idea with Flycs is that with Flycs, it's to reduce the amount of time needed from 4 quarters to only 2, because all that complexity about coming up with your own way of approaching a data warehouse, cloud native data warehouse, is predefined by Flycs. All the idea of how to manage PII fields, it's predefined and very well defined in Flycs. The DevOps as well. The DevOps strategy is defined. So a bit of the DevOps ecosystem. For the developers then, it allows to have a clear future branches, so to have their own branches, and in that branch they are allowed to do everything. And by everything, I mean that they can really change everything that they want without even committing to development yet. So that's very powerful. They can really have their own sandbox to test as many things as they want. And once there is, once the future is ready to be merged into development, then they can make the pull request and have it ready for development environment. Another important thing to notice is that what happens if 2 developers are conflicting into each other, trying to work in the same transformation. Maybe a developer made a change in one of the field names that the other developer is referencing. All of that is easily to catch by using branch and development branches and merging into a development, because the conflict will show up, and then it's just a matter of fixing that conflict. So that's even before going to production, right? You don't need to wait until it's in production to try to fix those issues. So how does it look like for the developers? The developers are actually just pushing the code to a GitLab repository, and the GitLab repository will do everything. We will come with, it will be possible to then just define, it will resolve all those task dependencies, will resolve all the different SQL statements defined, and to know what needs to happen first and what needs to happen last. And then finally, when the branch is ready and it's ready to be merged into development, the development environment itself will be as well clearly splitted from your release and your production environment. That allows to test even further in development the same thing in release and production. And the interesting part is that the way to deploy to all those environments will be consistently done the same way. Just basically clicking two, three buttons, and it will be done in a consistent way. A couple of use cases. There is something called right to be forgotten. So the right to be forgotten, that means that any customer at any given time can ask, I want my data to be gone. And some companies might think, okay, then I just delete the record. And that's not maybe the most smart thing to do, because that doesn't mean that you didn't sell something to one of the customers. You will just have no linkage to whatever happened there. Other solution might be try to hash all whatever name you find of that customer across all the different tables. And it's also not a smart solution, because then you risk the possibility of not hashing or not changing the name of one of your customers in one of all the different transformations across the whole data warehouse. So how to tackle this one? With Flycs, you can just delete one key set, and that key set, as soon as it gets deleted, it will be impossible, and really impossible, to decrypt the information for that customer. So it is possible to use, say, I want this customer to be deleted, or I want this customer data that is linked to the name, or that is linked to a bank account, to the address, and all the stuff used to be deleted. The data will remain there, but it will be impossible to decrypt. So analytics is still possible on top of that data, so that you don't lose track of that you sold something at some point to an existing customer. Maybe you will not be able to know to which customer, but it will still be there. Another possible thing with Flycs is that with Flycs you can come up and do for 15 different databases, 200 plus transformations. You might feel tempted of coming up with 200 plus transformations by hand, really writing each one of them, which might not be the best solution for a data lake. So instead of doing that, with Flycs you can come up with templates. With actually it's something that we did for a customer. With 4 different customers, we managed to make a data lake of 200 plus different tables. So that means that if the customer in any other point requires to add an extra column or something specific across all the different 200 tables, it should be possible, because we can just add it very easily to one of the 4 templates. Right? In other situations, you will need to write this by hand. Another use case, the idea is to keep up the future branches. That means that all the developers have their own branch, and they will not be conflicted to each other, and to really test everything in each one of the branches. Inside those branches, once they get deployed, everything it's deployed for you. So that means that if you reference to a data set that should exist, then that data set will be created. The full DAG for the Airflow Composer is also deployed and tested before even pushing it into Composer. So by the time that needs to be developed, that needs to be merged into develop or push to production, it's going to run very smoothly, because it was tested previously in a sandbox, it was tested previously in a development, and everything that needs to be created is created. For example, if a new table is created inside those transformations, once it gets deployed, it will be created for you. In Flycs, it's not only about transformations, but also about custom code. With the custom code, that means that you can do pretty much whatever you can do in Composer. That's why it's important that Flycs leverages Composer. So it is possible to do things like custom code to, at the end of your DAG, you would like to make a call to an API to let the API know that your processing is done. Or another case scenario is you would like to manage your ingestion to your data lake. And to manage that ingestion, potentially, you could have a G-key cluster running, and then from Composer, launch all the jobs, different jobs, to then really extract the data, to then put it into BigQuery. That's another possibility that can still be, it is possible to do within the Flycs framework. Another use case as well inside Flycs is that you can keep track of all the different fields that are coming from the data mart, data warehouse, and there is a clear data lineage for all the different fields. Where is it coming from? If it's the customer name that you found in one of the data lake tables all the way to your data mart, it is possible to really see it, where is it coming from, that lineage. Important topic as well is the possibility of data leakage. So you may want to expose a bit of your data mart to a customer because your customer wants to do some things on top of the tables on BigQuery itself. So instead of giving them access to your data warehouse or instead of giving them access just to a data mart, what Flycs allows you to do is to have a clear separation by leveraging good predefined GCP projects to say, okay, this data mart needs to exist in one specific project. So in case that the customer gains access to only that project, will be only possible for that user to have access to that and that only. And that's it. Any questions?
Hello, hello. Hi, thanks very much for the presentation. I've got a few questions actually. One of them is on the right to be forgotten. You mentioned that every piece of private data can have an encryption key.
Yes.
Doesn't that become a huge management issue in itself, managing all the encryption keys? Or?
Yeah, but that's the part of Flycs. So the Flycs, what it does is going to create those key sets for you. That means at the beginning of the DAG, maybe I have the sample here, but the idea is that here. So normally what happens at the beginning of the DAG, all those key sets that are needed for your raw area, for your data lake, will be created. And then the decryption and encryption needed to make the transformations on top of a PII data are also resolved by Flycs, because Flycs knows where the data is coming from and really can say, okay, this field is coming actually from a PII field all the way from the data lake, and from there decrypt it and then encrypt it again to be able to transform it. So
Flycs manages all of that for you?
Yeah, encryption and decryption for transformations on top of PII fields.
Okay, and then another question. You talk about data lakes, data warehouses, data marts. Are we copying that data across all of these layers, or are they just views on one bit of data? Because I'm just wondering, it becomes an awful lot of data that we're storing, and eventually it becomes expensive.
Yeah. So, the output of the transformation can be a view or a table. At some point, you will like the transformation not to remain only a view, but also a table, especially when it comes to aggregated data, and because it's when it comes for enrichment of data, right? So, what sometimes can happen is that your data mart is actually purely views, and your data warehouse are actual tables, right? So it can be both. You can say my output is actually just a view, or my output, you can define that.
Because if you have tables, then do you not have reconciliation issues? You've got to make sure that data is in sync between all these layers?
Yeah. To do that, then you need to make sure that your DAG is well defined and that the tasks, that's why task dependency is important. So in that way that when you want to build, for example, the customer table from the data warehouse perspective, all the different data lake tables for your customers are already there for your data warehouse transformations to kick in. So that's why task dependency is important.
Yeah. Okay, and then my final question, you talked about feature branching.
Yeah.
When you feature branch, do you also take copies of the whole data mart or the whole data lake for each feature branch?
Yeah, no. You can do that, but no, it's not the data itself. So depending on how the project is set up, one of the ways that you can set up the project is that the sandbox is pointing to the raw area of development. And then you will have as much data in your sandbox environment as you run your DAGs using that raw area from development. So it really depends on how you set up your project. The idea of the sandbox is for the developers to test, but not for a data quality. Data quality comes more in the UAT stage. So it's really to have a small subset of data where developers can test up here and there that the transformations or outputs are correct, that the DAC is running correctly, and then do small data validations, but more like in-depth data validations are actually done in UAT, where depending on how the project is set up, you might be able to use production data or UAT data or even development data.
Cool. Thank you. Thanks very much.